Hello everyone and welcome to our new Real Virtual I/O tutorial. In today's video, I'm excited to show you how to work with large CAD data and how to import them into Real Virtual and Unity. It's important to note that the majority of the content covered in this tutorial is exclusive to our Real Virtual I/O professional users. However, even if you are using our starter version, I'll guide you through the process and teach you how to use large-scale mesh data. Also, the CAD interface, CAD checker and selection window is not included in the starter version. So let's dive in. I created a new scene because today we are not doing something based on the things we created in our tutorials before. First of all, I'm going to add the CAD link interface. As noted before, it's only available in Real Virtual I/O Professional. With this interface, you can import CAD data based on step format and soon also based on JT format. You need to use it if your CAD system is not having any kind of export option in the formats Unity is able to read in. Unity is able to read in OBJ, CAD and FBX files. If you don't have these three file types available as an exporter from your CAD system, more or less all CAD systems provide the ability for exporting step files. I'm now going to import a step file, so I'm selecting it. Here's a step file. It's not too huge, it's quite small with 50 mega. I'm selecting it, and for the quality first, just for demonstration purposes, I'm using the ultra quality, so the very best quality. And I'm importing the CAD file into my scene. This might take some time. So here's the result of our import, and I'm showing the shaded wireframe mode. And as you can see, it's very detailed. So for example, let's take this screw and maybe isolate it. Not this one. Show this one and isolate it. In wireframe mode, so this screw is very detailed and maybe much too detailed, and we could also check the number of meshes with the CAD checker. Put it here, and I need to drag in the full assembly. Here it is, and as you can see, we are having in here 4 million triangles, so it's a very huge design, and I imported it with the highest quality, and that's an unnecessary high quality. So let's delete it and import it again with another quality setting. Let's use high. And I'm importing it. So here's our high imported CAD data. And as you can see, it's a little bit more rough, but still it's really okay how the components look like. And if we go again back to the CAD checker, which can be opened here by CAD checker, and check, we can see that we reduce the triangles more than by factor 3. So we are now having about 1 million triangles in here. So that's quite okay. And in general, you should select between low, middle and high, and always use the lowest quality, which is getting you still a good visual appearance, because if you are going to reduce meshes later on, that will get you a much less quality if you don't reduce it based on step data. And currently you need to do it with external tools, but we are currently in the next release preparing also an included mesh reducing function, but please always import it as much as you could do on the first import. That's very, very important. This design is having about 1500 parts, and a good way for working in big CAD designs is to use the selection window and for working by working with groups. So I'm defining a new group, let's call it frame, and I'm selecting something, this here, or maybe this full thing here. And you should select here on the selection. I know here the selection wire, that is giving you a better feedback what's selected. That's the orange wire around. So if you are selecting this one here, okay. We are moving this also to the group, or we are moving this to the group frame. And now we have created a group, and it's not shown the frame. So I can select here show and hide of a group. And by doing this, I can easily move things to a group. I will get a feedback what's defined to the group. And let's put that, for example, also on these screws to the frame. Also this screws to the frame. Edit this to the frame. And with show and hide, we can show it, or we could isolate our frame. And that's giving us a really good way for working with large CAD data, because we can every time hide and isolate specific things which we would like to see. So that's the selection window and the group function. And if you've got a lot of groups, you could use here the small group window, and you are getting a better overview over the groups. So let's define additional groups, and now, for example, for the kinematic. So this, for example, is our row axis 1. Oh, let's go to robot 1, axis 1. That's here our axis 2. That's here our axis 3. That's our axis 4. And that is here our axis 5. And maybe everything which is sitting on, that's our axis 6. And for the moment, let's put everything which is on top of here also to axis 6. So axis 6, axis 5, axis 4, axis 3, and so on. And the axes are shown in here on the right hand side of our hierarchy view. and for creating my first kinematic, and for being able to move the robot a little bit, for showing you performance impacts, I'm going to add the kinematics in here. So let's add a drive and a kinematic to all these components. And for the moment, I don't care about the detailed positions and directions of the drives. Maybe just the first one. Let's make it a rotation about the y-axis, for making it rotate a little bit. And on the kinematic side, let's integrate the group here, axis 1, here, axis 2, and so on. So just for testing purposes, on the first axis, I'm adding here the drive erratic position, and I'm moving it from, let's say, -90 to 90%, 90 degrees with a speed of 30 degrees per second. And let's show again everything, and we are going to start it. And our first robot axis is moving around. As you can see here, currently our graphic cycle time in editor, so in build time it will be faster, is something between 19 and 21 milliseconds. And one very important thing for improving performance and working with large CAD data is that everything which is outside of moving axis, so basically the most part of the design, and that's why we are first taking this, should be static. And we are now changing everything to static. And just for our axis components in here, we are defining it as non-static. And this enables Unity to optimize a little bit the meshes and the rendering during simulation mode. And I'm checking it again by starting the simulation. And you see that it's now between 13 and 15 milliseconds. So it really increased our performance by about 30%. But we have forgotten something. So this one here, I think it's all this here. I think it's everything in here. Our components also non-static, yes, and change children. So now the full robot should move. And still with an improved performance. So using static, non-static setting has really an performance impact. Okay, I've forgotten some screws in here. So basically, how do we get them? Or maybe we just hide here. So everything should be in. But I think... Okay, these are still static. So non-static. Another way for doing that would be by selecting here everything axis 6, everything is selected, and then I could select here static and non-static. So now it should be fine. And we still have here our improved performance. So static and non-static has, I would say, the second performance impact besides importing the lowest possible mesh quality, which is still getting you a good rendering quality. Another thing which is impacting performance is the number of meshes and materials. We have got a tool included in Real Virtual, which is called Performance Optimizer. You can edit by add Performance Optimizer, and you could use it for baking automatically meshes into one mesh, and it's taking into account the kinematic components and groups, so that it's only baking meshes into one mesh which are together. So we are doing here optimize, and you could say yes, it could be reverted later on. And as a result, I could turn this fully off. All the meshes in here are, if we look onto it, are turned off. It generated optimized meshes, so all the robot axis 6 and all the static components are in one single mesh. But if you look on it, on the materials, in this one single mesh, there are 1264 materials included. He will now use for simulation this optimized meshes. So pushing on play is doing the same, but our performance didn't improve. And that's the case because our optimized mesh is having so many materials in. So let's undo again this optimize, and I can do it by undo optimize. It will delete everything and it will reactivate again the original meshes. And if we look in here onto our mesh, we will see, yeah, it's a mesh which is included in the scene itself, so it's not an instantiated shared mesh. And that's the problem or the issue, because all the meshes are getting their own colors and materials. And for preventing that, in the import section of Real Virtual, I could select here set and create materials. I could do it upon import, but I can also just do it now, and I could select update materials. And what he did now, checking again a mesh, we will see that the material is instantiated, and he created for each new material, based on the hex number of the color, a new back again, he created for all colors on the import side of the step file new materials, but for each color only one material. And so the model now references to the materials in the assets folder. And let's do again the performance optimization. So we are going to bake all meshes to one mesh. Yes. And let's check again the results in the optimized meshes. we are now having a limited number of meshes within this optimized mesh. So let's check the performance. And as you can see, performance really drastically is reduced. It's now 4 milliseconds. Before we had about 20 milliseconds. So baking it into one mesh and reducing the material is really having bigger models a high performance impact. But what I would like to check again is, let's do it the optimized, let's undo it again and check now the performance. So we are still having the instantiated materials, but the meshes are not baken. And as you can see, the performance is a little bit reduced. So before we had about 20, now we are having 14. But by baking the meshes, selecting optimize, our performance is really improving. And these optimized meshes, they are always in parallel. So you could always do undo. And basically we are just creating meshes for each kinematic groups and for the static components. And we are turning off the old meshes. Yeah. And by doing undo, you can always get back. And the advantage is that you're keeping your original CAD structure still inside. You could change things, you could re-import and update your CAD design without destroying anything. So my advice would be work without optimized meshes as the start of your project, and at the end, if you are seeing performance issues, you can always optimize the meshes and use the optimized meshes within your digital twin. Let's talk a little bit about materials. Currently in this scene we are having still the imported materials in. They are flat colors and not of a very high quality. They are just standard materials. I'm going to undo the optimization first. And you could always take better materials like these materials here and drag and drop them onto your model. For example, I'm pulling on here aluminum brushed. Another way for changing materials, for having a better look or for reducing the number of materials, is that we are having in here a material update function. Yeah. So and for the material update, we need a material update setting, and I'm going to create this in here in my tutorial folder. Let's create a new game for automation material update setting. It's called material update tutorial, and I'm gonna assign that here. And the material update setting is basically a list of mappings between current material and new wished material. So for example, I'm creating the first mapping and I'm going to select my source material, and my source material should be the one from the import, because we are just still having the imported materials in here. So the automatically created materials, and the white should be this one, and so the FFF, and as you see, all this is FFF. So in my material update setting, I'm taking this source material, so the color FFF, I think it's called this one here. And that's my source material, and I would like to assign a new material, for example, my material aluminium brushed. And now I've got the first setting, and maybe let's take also this material here. That's the coal. This one here. And okay, maybe it would be better and easier my material update setting to open it in a new window. So let's open here a new inspector window, and we will block that. I'm having here now my material update. So if I'm selecting this color, the black color here, I'm dragging that to my second setting, and here I would like to have it as my plastic black. So I defined two settings. And within my selection window, I'm now able to select my full scene or my full model and select here material update. And this will automatically replace all materials based on my setting. So that's a fast way for replacing materials in a bigger scene. For example, replacing certain colors against better Unity materials. We're at the end of today's tutorial. To summarize, you are having a lot of features within Real Virtual for working with large CAD data. First important step is always import in the lowest possible mesh quality, which is giving you still a good visual look. Second thing is always use static and non-static setting. Third thing is reduce the number of materials you are using. You could use our performance optimizer for baking the meshes. And as I've shown you, we have been able to reduce the performance of this demonstration model from about 20 milliseconds of time for calculating each image in the editor to 3 or 4 milliseconds. So it's a huge performance impact. And you've learned how to use the selection window and cut checker for working with these large assemblies by defining groups and navigating in your model. Thanks a lot for today, and we are going to have a new tutorial next week. And if you like our tutorials, please subscribe our YouTube channel. Bye bye.